In this video, we will see how to implement Diablo-like movement in Unity. We're going to explore how to add jumping mechanic to our movement and also how to ensure that our character plays the correct animation. This will be a two-part series where first we are going to set up the NavMesh movement, and in the second video we're going to add jumping. I have prepared a very simple dungeon level to implement our navigation system. The assets are from Voxel Dungeon Crawler Pack, the link will be in the description. To implement our movement system, first we need to bake a NavMesh into our scene. To do so, we will need to get the AI navigation package that contains all the systems necessary to create our movement system. To grab it, we need to open the package manager, make sure that you are in the Unity registry and type AI in the search box, and you should find the AI navigation package. Make sure to install it. You can also grab some sample projects by importing them if you want to see some other examples how to use it. Next, what we need to do is go to the hierarchy and start creating our NavMesh surface. To do that, let's go to the plus icon, create a new game object, call it navigation, and let's add to it a new component called NavMesh surface. You will have a lot of those components here. We're going to select the NavMesh surface, and this will allow us to generate our NavMesh to bake it based on some settings that we have. Before we can go any deeper into how they work, we need to focus on the Objects Collections tab, which allows us to select what objects should be taken into account. By default, it is all game objects, but we can narrow it down to the hierarchy of the currently selected object. What is more important for us is the include layers, which we can define a layer that should be included of all the game objects to be taken into account. We also have the option to select the render meshes as the base for the generation, or simply use the colliders applied to those. So what we are going to do is go to the top right corner of Unity, select layers, and we are going to edit them and add a new layer, for example ground. And now I have those prefabs that my floor is made of, and all of those are in the path subfolder, and they define all the walkable areas. This also includes those catwalks. So I will select my path, and I will select the layer in the inspector ground and apply to child objects as well. One more thing to do is to make sure that you set this to be static, especially we are after navigation static, and we need to just select this checkbox, and we need to select yes, change children to apply the static toggle to all the objects that represents our path, or you need to just apply this to each object that represents your ground. And this should be it. So now I'll select my navigation, and in the inspector I'll select the include layers to be nothing and next the ground. And now we can select the bake button, and after a while, if you have the gizmos on in the scene view, you should see that the NavMesh was baked. This is the blue outline showing up. If you do not see it, you either didn't include the correct layer or didn't set it to the correct objects. Now we can explore how it was baked, and if you see something strange or something doesn't fit the area that you have selected, this is where we need to tweak some settings to adjust the NavMesh that was generated. So let's select the navigation object and the NavMesh surface component, and here we have a bunch of settings that we can tweak. Well, by default, the agent type is defined as humanoid, and if you have downloaded the samples, you should have some additional ones. But what we want to do is select the Open Agent Settings from this dropdown. A new tab should appear, and basically here you can define what are the settings and what is the size and the height of your default agent that will be moving through your NavMesh. The most important settings here are the radius and the height, because based on this, if we set it to something high like 1, and we go back and bake our mesh, you will see that this catwalk is too tiny for the character to walk, because the character is defined as having 1 meter of radius. So we want to tweak those settings to 0.3 back to the default value, and the height, if you have some low areas, you may want to tweak it as well. And in addition to that, you can define the step height, so how high can the player step before it needs to jump or climb on top of some surface, as well as the max slope. So it is this slope, what is the steepest slope that we can walk on, and what is too steep to walk on, and we need to find another way around. So this is what we can for now tweak, and if you have it, you can go back to your navigation and back again. And you can see in the scene view again, we can walk through this catwalk because we have the NavMesh agent defined as having 0.3 meter of radius. Now the remaining settings that we can tweak are in the advanced section of the NavMesh surface, and they are override voxel size, override tile size, and minimum region area. And we can also build the height mesh that generates a more accurate height mesh, and this is a bit more precise but also slower. You can read more about those settings in the NavMesh surface documentation, but basically the voxel size gives you a more accurate surface representation that is useful for smaller areas, and for big outdoor surfaces, open worlds, you should increase the size to kind of decrease the accuracy but improve the performance. The tile size is similar, it allows you to adjust the performance but lower the pathfinding result. And the minimum region area allows you to call the small parts of the NavMesh that should probably not be accessible. In the scene view, if you want to have some objects that needs to be obstacles so that the player cannot walk through them, in the inspector all we need to do is add to them NavMesh obstacle and select the curve inside the NavMesh so that we remove the part of the NavMesh taken by this obstacle. But there might be those surfaces that should not be included because they are too small. And this is what our setting for the navigation NavMesh surface minimum region area can help us fix. So now we have the baked NavMesh surface, so we'll be able to move our character across it, but we still haven't set up the character properly. The next step is to select our character. In my case, I'm going to use the animated character provided by the package, and we need to add to it the NavMesh, and we should have the NavMesh agent. In the scene view, you will see that there is the cylinder, a green cylinder appearing that looks a bit like a collider in Unity, and that's what is representing our character. In the inspector, we can change its radius to adjust it to the size that we have applied to bake our NavMesh, so 0.3, and we can decrease the height just so that it is above the head level or the hair level of our character. We can also go to the inspector, and if our cylinder is not appearing at the feet of our character, we can use the base offset to adjust the position of our NavMesh cylinder, because the bottom of the cylinder will appear on the NavMesh surface, and that is how we can adjust where is our character standing. The next step is to implement the player input so that we can click on the surface of our NavMesh or in the region where we can move, and then we would direct the player to move there. And to implement that, we need to go back to our layers, and we need to edit it and add a clickable layer so that we can define the surfaces that can be clicked on. Now in my scene view, I have the map created out of those prefabs, those 3D models. So each of those will have to have a collider for us to be able to detect the click on it. And I don't want that because all of those colliders would take a lot of computational power. So I want to instead go to the hierarchy, create a new 3D object, and I'll use a quad. We can select it and press F to go and find it, and we can see that this is our quad. We can go to the inspector and to this rotation and set the rotation to be -90 or 90, just so that we can see its surface. Next, all we need to do is move it on top of the surface where we want to be able to move, and drag it just above it. And now we are going to scale it to fit the area that we are able to traverse. And we are going to use the X and Y to kind of extend it so that it takes the whole area where we want to be able to move. Now, as you can see, I have placed those quads around my map so that I have those areas selected for clicking. And if I make sure that it is just above the surface, I will be able to click on it. But basically what I'm after is to select all of those quads in the hierarchy, select the layer and select clickable. Now we can disable or remove the mesh renderer and the mesh filter, because all we are interested in is to have those colliders that we can select using our mouse pointer that we can raycast. So what we can do is create an empty object called clickable or input, and we can drag all those quads to this game object, make sure that we can select those to be static. Now to optimize this a bit more, we can also select all the quads and remove the mesh collider and instead use the box collider so that it is still a bit more performant. Now we are ready to read the input from our clicks. What we will need is a new script, for example player input, and I will add here the public event action vector3 on mouse click so that I have a way to send to other scripts the information about the position selected using our mouse. Now I like to split my code into multiple scripts because it is more maintainable that way, so that's why this will only contain the input. We are going to raycast onto the planes that we've called clickable, so we will need to have raycast hit underscore hit info equals new, and we are going to have a public layer mask click layer mask. This will be a way for us to limit the detected colliders to only those clickable objects. We're going to have a private void update method, and here I'm going to use the old input system by calling if input.get mouse button down 0 is the left mouse button. Then we are going to use var raycast, so we are going to create a raycast using camera main screen point to ray by getting the input mouse position. And next we are going to check if physics.raycast, and we are going to raycast ray origin, so this camera ray direction, so from camera towards the ground, and we are going to use out underscore hit info to save the information in it. We're going to use 100 as the distance from the camera which we are going to raycast, and click layer mask will be the filter with which we are going to only detect those objects. And if this returns true, and it only does when we have detected a collider and saved it in the underscore hit info, we're going to call onMouseClick !invoke passing the hit info.point, which basically is where we have clicked, and we are going to debug.log selected position is, and we are going to use the $sign so we can pass in the brackets underscore hit info.point. If you want to test it, make sure to save this script. Back in Unity, I want to add it to my players. I will just add it to the character player info and make sure that to set the click layer mask to be only the clickable. And now if you press play, you should be able to click on your ground where you have defined your clickable area, and in the console you should see selected position and some printouts. This means that everything is set up correctly. Next, to perform the movement, we will need to inform the NavMesh agent about the input. And again, I will create a new class called AgentMover, and then we are going to have a serialized field private NavMesh agent underscore agent so that we can get the reference to the NavMesh agent component. Another public event action, so a delegate event that will be passing a float value on speed change. Again, I will use the events to inform other scripts such as our animation script about the changes to the speed of our NavMesh agent so that we can play the correct animation. All I will have here is a public void set destination, and this will get the destination sent by our input system and apply it to the agent.destination equals the destination. So this is our input, our raycast result. And now to update our animation, we are going to have the update method, and in the update I will invoke on speed change. And to calculate the speed limited to the value 0 and 1, when 1 is max speed and 0 is standing still, I will use the agent.velocities.magnitude so that we can get the length of the velocity vector, and we will need to divide it by the maximum movement speed, again defined in the NavMesh agent. Before we add our animations to our character, we will have a player script that will tie everything together. So we will have a serialized field private player input with the underscore, and serialized field private AgentMover movement with the underscore. And in the start method, I'll just call underscore input.onMouseClick, so the event that is sending us the information about the clicked position. We're going to use plus equal to add to it a listener movement.setDestination, since it also takes in vector3, and this onMouseClick sends a vector3, so we are going to inform our AgentMover where we should move. Make sure to save all the scripts, and let's set the player up. All you need to do is select your character and make sure to drag here the player AgentMover, and we should already have the player input. We need to assign the agent reference to the AgentMover and to the player both the agent mover and the player input. And now we should be able to press play. And I can see in the console failed to create agent because it's not close enough to the NavMesh. Now my error is that my character was set in the NavMesh agent type to be humanoid for navigation sample, while in the navigation I have created the agent type humanoid. So I'll need to select one and I will change it for my NavMesh agent to humanoid. Now no warning has appeared, so I should be able to click on the map and I should see my agent floating around because it has no animations. Also, it cannot really move between those two areas because it cannot really jump. We haven't set it up. Also, the movement itself is pretty awkward, so let's pause it or actually stop our project, and what we can do is select our character, and in the inspector we can modify the speed and the angular speed. We can also modify the acceleration, so let's set the speed to be something like 5, angular speed, so the rotation speed to be 800, and acceleration I will set mine to 30, although feel free to set it differently. We can also modify the stopping distance, which will allow us to be safe that our character will not walk around in circles, because it will stop, for example, 0.3 of a meter from or a unit from the destination. Let's press play again. Okay, and now our agent should move much more rapidly, which will look much better if we have the animations. To create the animations, I will use Mixamo. I have uploaded the character and I will use the run, idle and jump animations. Now make sure to set in place it to be true, because otherwise you will see that the animation is actually moving your character, and that's not what we want for our setup. The imported animations will look like prefabs. If you want to edit any of those animations, you need to expand it and select it and use Ctrl-D to duplicate it. This way you will be able to add events to it. All we need to do is select our character and add to it the animator component, and we will need to right-click in the Projects tab, create the animator controller, and just select again the character and drag the animator to the animator component. And let's go to our animator window. The setup that I have created will be that we have two parameters, a float called movement speed and a trigger called jump. Next, we are going to right-click, create a blend tree, and I will call it movement blend tree. And this is because if we double tap on it, we can create a blend tree where we set up two animations. We need to go to the inspector, and here we will make sure that you check the parameter to be the movement speed and add, using the plus icon, motion fields, two of them. One will contain the idle animation that we have downloaded. The second one will contain the run animation. And the idea is that if we have the blend tree, we can move the animation and change it between the idle and the run animation based on this movement speed parameter. And this is how we are going to transition between idle and movement. And we are going to also have the transition to the jump animation that we have downloaded. And this will be a simple transition based on our jump trigger. And it will have some transition time in the settings, 0.3 of a second. And forward and backward, it will have the exit time back to the movement blend tree. When we have our animation set up in the agent animator, we will need to have a custom script agent animation. Again, I have created a separate script to control the animator. We will need to have a serialized field private animator _animator reference so that we can set the parameters on it. And I like to save my string names of this movement speed. So movement speed and jump. So this is the trigger. This is the float parameter inside our animator as a serialized private string so that we can modify it through the inspector. And since I want to add some step sound, I will have a public Unity event on step. And here are three methods that we will need. Public void set speed, and we are going to get the speed from our agent mover, and I will call _animator set float _movement speed. So this is the string name, and the speed, which is the float value between 0 and 1, of course. The public void jump will be used in the next video, animator set trigger jump, and I will have a public void step event that I will add to the animation of my running so that I can play the step sound effect. Okay, make sure to save this script. Next, we are going to visit the player script because it now needs to have a serialized field private agent animation _agent animation reference, because now when we are going to call movement dot on speed change, we're going to assign the _agent animation dot set speed so that it can send the message to our animator. And obviously at the beginning we want to call AgentAnimation.setSpeed to be 0 to ensure that we are playing the idle animation at the start of our game. Make sure to select your character, and beside the already existing scripts we are going to drag the agent animation, and we are going to assign the animator here. We have the movement speed and jump trigger, and on step sound I have in my player the step sound. I will just add the plus icon to add a listener step sound, and I have the audio source, and I have play method so that I play this sound. In the animation window you will see that the run animation has those events, step events, wherever my player, let me focus on it, is performing the step. Okay, to try it, we need to, of course, go to the player and assign the agent animation. I forgot about that. And if we have all that in the character scripts, we are going to press play. And now, when we play our game, we should see the idle animation and the movement animation playing based on the speed of our NavMesh agent, and it looks pretty nice. We still can't really jump. We are going to implement this logic in the next video, so see you there.